time to determine if the ball accelerated during that 4-second period. So let's draw our picture. The ball was first moving at 2 meters per second this way. We ignore the turnaround time. It is then moving 2 meters per second the other way, and we're looking at the entire interval, 4.00 seconds. So if you did this, let's see what happens. If you use the definition of acceleration, A is v minus v0 over t. This would be v, the final velocity. This would be v0. If you did this, 2 meters per second minus 2 meters per second over 4 seconds, you would get 0 meters per second squared, which is not correct. Remember, we're going to ask ourselves, did the velocity change? If the velocity changed, the object accelerated. When you only look at the magnitudes of the velocity, you're not looking at the entire picture. It is true, the magnitudes of the velocity did not change, but velocity is a vector. The direction changed. If any part of a vector changes, it is changing. It is not constant. This is the importance of always defining an axis. Without an axis, you could be in trouble. So, let's define our axis this way. If we call positive x pointing to the right, this is what we should get. A, v minus v0 over t. Since the final velocity is opposite our axis, it would be negative 2 meters per second minus the initial 2 meters per second over 4 seconds. So that's negative 4 meters per second over 4 seconds, or negative 1.00 meters per second squared. The negative does not mean slowing down. Negative means the acceleration vector is opposite to what we call positive. It simply means that A points this way. It does not mean slowing down in this case. So we have to be very, very, very careful. Many people think a negative acceleration means slowing down. It does not. In this case, it clearly did not mean the ball was slowing down. Have to be very, very, very careful.